Hello, everybody, and welcome to another awesome phoenixNAP webinar. My friends at Vast Data are here with me today, and we're going to talk about everything network attached storage, how you scale that, how you enhance your compute infrastructure with super high performance network attached storage. My name is William Bell, Executive Vice President of Products, and I've got Rob Gerard, Principal Technical Marketing Engineer from VAST on the horn with me. Welcome, Rob.
Thanks, William. Thanks for having me. And thanks for everyone who's attending.
Great. All right. So let's get this thing kicked off. What we're going to do is we're going to ask you a few poll questions. So if you guys could jump on, answer quickly, we can walk through these, and really make the most out of today and target what you're looking for. So we're looking at data hungry workloads. What do you guys have? What are you working with? What's really driving data storage consumption for your organizations? I assume it's probably all of these, but we'll see how that works. It looks like, okay, yeah, databases makes sense. HPC, all right, analytics. Although I find they're slightly different in terms of the use case, I mean, that tends to make the most sense. All right. How much storage are you guys working with? What's that mean? I'm gonna guess it's probably 10 to a petabyte, but we've got a few larger customers out there, so maybe it's a little over that number. Everybody click that button. All right, that makes sense. Okay, good. Well, the good news is that for all of you guys on the call that have large data sets, this is going to be a great conversation to have. And the guys that don't, if performance is a conversation point, even if you don't have a ton of data stored, you're also going to find today's conversation super valuable. Last one, I promise. Okay, so what's bugging you, I guess, is the best part to put this question. Like, where are you struggling from a data perspective? Is it the computational side? Is it the cost of storing it? How to use it? Like, what does that look like for your organization? Okay. Data is hard. Got it. I think that's the easiest way to say that data is difficult to deal with. So it makes sense. All right. So we're going to start by covering the broad strokes of why not only are you struggling with these problems, but what our partners at Vast Data are doing to address them. And ultimately, when you look at the curve associated with data storage and data growth, it is essentially exponential, right? We're in a place where data is growing at rates that are just unfathomable years ago. 180 zettabytes by 2025. I honestly think that, especially with the recent things coming over the wire with the enhancements to AI and Midjourney and GPT and things like that, that probably is going to be a low number, but I guess we're going to find out. I think we could all agree that like data analytics, data usability is kind of the key core problem. I've got all this data. What do I do with it? How do I access it? Even if I have good tool sets to mine the data and get insights from it, a lot of times the infrastructure can't keep up with that either. So you end up in kind of like this two-sided bottleneck where it's like, okay, I've got infrastructure not quite keeping up, and then when I get the tooling and the code that I've written into a place that makes sense and is performant, then the storage is the problem. And so the team at Vast has been working hard to address that. We're making their technology accessible to everybody in an on-demand fashion, and I think that's the real value you're going to see out of today. I think that when you look at cloud-based storage, especially as it pertains to call it primary storage, it is a place that is still somewhat mystical in terms of, at least from my perspective, as to why it costs so much and why it doesn't perform as well as it should for what it costs, right? And so I think that while there's infinite guides out there to make a technology like you know, the like EBS as an example, or Google Storage, go fast, the costs associated with that tend to start spiraling out of control. And while there are ways to mitigate that, even it makes for a lot of complexity. And so we're trying to figure out ways to make that easier. And as you're trying to keep up with the growth of the performance angle and the data storage angle at the same time, it makes it very difficult. And I think that people are running towards cloud providers because it allows you to be less predictive about your growth and just continue to consume as you need. The problem is the cost of doing that has not really been right sized. EBS pricing is a good example. It made sense maybe 7 years ago. Even when like, GP2 came out, right? It kind of made sense in terms of like all flash. But the reality is that today this pricing hasn't really been adjusted to what I believe is necessary to be scalable for organizations. So, as you start to figure out where you're putting all this data, who is managing it and how is it being managed, we do think that there's like this two camp situation going on. You've got a lot of people taking all their large data sets, continuing to process them in on-prem and colo, et cetera. And then you have people that are taking all their general purpose workloads and trying to park them in public cloud. But then they realize that there's this like gravity problem. They've got all these apps in public cloud that need access to high performance storage. The data sets that those apps are generating are growing. And so they start to find ways to consume the data on that end, the high performance storage on that side. Then you have the on-prem side, where you might be comfortable with keeping up with your data growth and buying predictably on the storage side, but then you have compute problems that go along with that, where you end up in these weird cycles where you're not kind of getting it all together at the same time. And so ultimately, the hybrid approach is better, but because of the gravity of data, especially in high performance workloads, hybrid's a little bit of a misnomer, right? Like there's no way to do the computational work in like our phoenixNAP bare metal cloud while the data stays resident 50 milliseconds away on EBS. Like that doesn't work, and kind of vice versa, right? And so what we're finding is that people have to find the right cloud provider, infrastructure provider for the entirety of that application, and then be selective about which applications go where, and then network them together to make the hybridity. And so I covered a lot of these already, but when you look at this on-prem infrastructure idea, you get to know where your data is at, you get to control it in a very fine-grained way. But the lack of the unpredictability of the data generation, especially of application engineers that you might be working with, leads to all kinds of problems, not only cost and capital problems, but just this idea that 2 petabytes might be enough today, and then some application engineers come up to you and say, hey, we need more storage now, we need another petabyte, and you're just like, I can't materialize that, that's not how this works. And so you look to kind of the public cloud as this savior for those types of use cases, but the way you interact with storage changes, the way that you pay for storage changes. You've got all kinds of things that you never had to worry about, like egress fees and things like that when you want to do something else with the data. And then you end up in this costing nightmare that's not really easy to deal with. So as we move to the next slide, we want to try to find the things in our way to making this easier and the solutions that we can use to address them, right? And so when we look at these kind of the high level categorizations of what's standing in your way to being efficient with data, we think that it starts with just finding a way to extract the data out of the large data sets and complex data sets that you have in your environment, dealing with that growth is challenging just from a understanding perspective. Meeting that with the infrastructure components and dealing with the hardware lifecycle that goes along with that, the continuous capital investments, the other skill sets that you have to maintain inside your organization to manage it. And then as in this transitional period, I guess, this is maybe a temporary problem, a temporary roadblock, but during this transitional period, which I think is lasting longer than everyone suspected it would, you've got this like, where do I put my data? Does it go on all flash or NVMe storage versus spinning disk or hybrid? And making the choice about where to put that data set. I think as technologies like QLC get better, PLC behind that get even better. Maybe we'll see this spinning disk thing go away eventually, but it just continues to hang around. So people are making those decisions. Even once you build the architectures to house all this data, making it accessible for other people can be an extreme challenge. And then aligning all that stuff we just talked about with this desire to modernize the way you manage infrastructure creates this discombobulation that I think most of you on the call are dealing with every single day. All right, so what can you do about this? Right, I think that this is what people are trying to find solutions to. They understand, organizations like yourselves understand that you need to help the line of business access compute and storage resources efficiently with immediacy on the right type of hardware infrastructure that the application desires, both computationally and storage architecturally, that you're doing it in a safe way with data availability at least on your mind as you're building out these capabilities around accessing data across an entire organization. And then where necessary, meeting that with modern technologies like scale out flash and NVMe, and making those technologies kind of core at the forefront of your organization in a cost-effective manner. So that, I think, is a summary of how you get to this. I think the marketing team wrote here this automation-driven OpEx model cloud infrastructure, right? And that's ultimately this somewhat nirvana that people are looking for. And I don't know that the public cloud has addressed it well. They have solutions, they exist, they are automated and OpEx, but I'm not certain that they're solving for this vendor lock-in situation, the visibility into the data and what's happening behind the scenes, and then control over that data, I think is difficult. So what we're trying to do, and we're going to talk about how we tie all this in here in a little bit and do a demo at the end. So you definitely want to see the live demo, because I'm the dummy that's going to do the live demo. So if you want to see that, make sure you stay. We're looking to take the data center to the next level. And we've partnered with a ton of organizations, Vast Data being one of them, to try to make this on-demand access to the data center a real life scenario, so that you can get the OpEx model that you desire, you can get the scalability and the immediacy of the infrastructure access that you desire, but without transforming your entire world, right? Like, it's hard enough to digitally transform the business without having to essentially rewrite all of your applications from scratch. Sometimes that's necessary. Sometimes that is a requirement, but not always. And I think that for many applications, when you just pick up and lift them directly to any of the public cloud infrastructure companies, it puts you in a really bad position. And I guess I said the wrong word. I said public cloud infrastructure companies. I think it's better to say that they're public cloud API companies, they're PaaS companies that make all of their best features available via direct proprietary integration. And I think that that's where people tend to run into problems. So what we're addressing this with a ton of cool features in our bare metal cloud product. We're going to talk more about network storage. I'll leave this here for today. We're going to distribute these slides as well, and obviously you can sign up and try it out anytime you want. And with that, I'm going to bring on Rob. He's going to talk everything VAST Data, talk about how awesome the things that they've done over the last 3 years have been, and then I think it'll become apparent as to why we're using them for our platform and how we can give you access to all this great technology in a consumption model. Go ahead, Rob.
Great, thanks, William. And as much as I would love to talk everything VAST Data, I don't think that you signed up for a 3-day webinar here. So I am just going to hit the high notes. We at VAST Data are a data platform company. This week we just put out a momentum release. Business is going very well. We've gone from 1 million of ARR, annual recurring revenue, to 100 million annual recurring revenue in the past 3 years, which makes us the fastest growing data infrastructure company to ever exist. So what are we doing that's making us grow so fast? Our mission is very, very simple. It is to simplify storage and break down those tiers. So the picture that you see in front of you is a depiction of how storage is done today, where on the left side, we have all these tiers that usually aren't there because we necessarily want that technology. So it's like flash and hybrid and backup, but archive. The reason these tiers exist is not because people don't want the fastest all flash tier for all, it's because the economics simply don't match that. So our mission at VAST is to put an end to the hard drive. Hard drives themselves they've served us very, very, very well over the years. However, when it comes to reading things, it can add a lot of unpredictability to it. You've got moving parts that have to grab data from different places. And so what we've done is we've set out to make a very simple, very highly scalable system that can eliminate all these tiers, and we just call that universal storage. So it would be good for any of your workloads. And how do we do that? This is the pieces that we needed to do this. Now, if I'm saying anything, you're like, oh, that's just like so-and-so, so-and-so. If any of those existed prior to 2018, then it is not like that, because the things that we're doing were not possible before that. These were the 3 technologies that helped us do what we do today. And until they were commercially viable, it would be impossible to do what we are doing today. And these 3 technologies are NVMe over Fabric. So this allows us to have an access plane for keeping lots and lots of storage available to the compute that's going to use it. And I don't mean the client compute, and I'll show in a minute, but not quite yet. Over low latency. So just as if it was a bunch of direct attached storage, but we can do it from a pool of storage. And then we're leveraging QLC Flash, and QLC Flash is very dense. Our drives come in 15 and 30 terabyte sizes per drive, which means our small chassis and stuff are upward, half a petabyte or a full petabyte in 1 to 2 U of space. So it's as dense as it gets. But Flash may not be, QLC Flash, while cheaper, may not have some the endurance you need and some other qualities. And so what we do is we augment that with storage class memory. And this allows us to take advantage of that in several ways. So we have an architecture that we call DAYS architecture. This is a disaggregated shared everything architecture. This is a method of creating a very giant scalable storage pool, all in a single namespace that can grow into exabytes. And is contrasted to how large distributed file systems have been done prior to this, which is primarily over like a shared nothing architecture, where you would have some storage per node, and then you have to make sure you copy that to another node. And all of that can add some complexity and a lot of complexity, especially when we start to get into failure design and stuff like that. So this disaggregated shared everything architecture is fairly simple. here's client. These are all the compute. This is the bare metal cloud in this case. And here's all the clients that you want to access. You come in through some virtual IP pools that are assigned to a whole bunch of C nodes. These C nodes are our container nodes. These are where all the CPU happens. And this is scalable for performance independent from the capacity. So these C nodes are then connected over an NVMe fabric, that low latency fabric, to deep D nodes, these data nodes on the back end. And these are where all that flash is stored. So we have lots of that hyperscale flash, which is QLC today, and we've got others coming out tomorrow, or proverbial tomorrow. And then storage class memory, which has typically been like an Intel Optane or Kioxia FL6, highly durable. And so what we can do here is treat that storage class memory as a giant pool of memory, keep all the state from those C nodes, and so that way those C nodes, the containers in them, can die non-disruptively, and all of them die right down to, it just takes one to serve the entire data set. And now all of this backend stuff is connected to the front end. More practically, what does this mean? Well, this makes a composable flash cloud. So this is, all of it is all flash, and this allows for one big namespace to be presented across as a unified front to all of the customers that are accessing it. And in this example, we've got in the picture, what you see are a number of these C nodes. And the first one there you see is customers. So you yourself would be coming in through this pool that phoenixNAP has set up through the VIPs that you will get out of their dashboard, which William's going to demo later. And this is how you as a client would interact with the storage. Now, why do you care about the back end? What benefits you about this back end is that let's say you grow your data a lot. phoenixNAP is not in a position where they have to start moving stuff around to fit you in with other customers, or like you've just run out of space on a certain box size. So hey, now you're gonna have to have 2 exports or 3. And you don't need a whole bunch of exports cobbled together to get that performance. This is a very liquid, scalable system that allows phoenixNAP to provide a very, very front-end, simple access to this storage, very high speeds, can take it up a notch by even dedicating pools to your front end. If that's desirable, you can speak with them. And then they can use other pools, such as like this backup pool, for example, to offer backup services and come in and access all of that without interfering with the way that you're using that storage. So that's it in a nutshell. Again, I could I could spend days on this, but let me turn it back over to William.
Awesome. Thanks so much, Rob. Yeah, we're super excited about this technology. You know, we continue to invest in making it, bringing the goodness that VAST is doing on their arrays that they sell to customers through our platform to our customers as an on-demand consumption model. And ultimately, this is our guiding light towards delivering storage in a data center as a service consumption model. And the goal is to take super high performance, make it easy for customers to deploy, automate all that. So Terraform, Ansible, API, whatever GitHub actions, whatever makes sense to you. Leverage the capabilities that VAST has to give us this kind of like quasi-infinite, and it's not, nothing's infinite, but we'll call it, for the purposes of what we're doing together, infinite storage pools that our customers can get a slice of quickly and make that cost effective. That is the key, right? Delivering all this goodness, if it costs, you know, $200 a terabyte, like, why would you do that? But bringing all that in together, and I think our on-demand consumption price is like 86 bucks a terabyte a month or something like that. So 8 cents a gig. No IO fees, no this, that, or the other fees. It's just how large do you want those volumes to be. So you get to choose from a ton of different servers. We'll probably won't spend a lot of time there in the demo. You get to deploy network storage on demand, and then access it via your instance that you've deployed. instantaneously. And especially if you deploy a new instance for the purpose of, which I'm going to show you in the demo, for the purposes of accessing the storage, we can automate more to make it instantaneous. If you have a already provisioned instance type, then you have to do a little bit more. You have to add that storage network to your server, that VLAN, and then give it an IP, and then you can access the storage, right? So there's a couple hoops in that side, but I'm going to show you all that. Yeah, I think ultimately, when you see what the technology can do from an ease of use, consumption, and performance perspective, it becomes actually harder to think of things that you can't do with it than it is to think of things that you should do with it. And then there is still, all that stuff exists. There's still a reason that scale out object tiers exist, where you have super deep glacier-like capabilities. Like, there is a place for that. And ultimately, but from a production primary storage workload perspective, I think this will take most of the cake. All right, let's do it. Demo time.
I can see it.
Yep. View. All right, great. So live demo. Here we go, friends. Okay, so we're gonna start with the what it looks like as you enter the portal. I already have some servers deployed here. We're gonna come back to this NFS benchmark server. We're gonna use that for part of our demo. But let's say that I have a bit of storage deployed already in Phoenix. So let's go over here to the storage tab, and you can see that I have a 2 terabyte volume created in the Phoenix region. Now I want to get a customer access to that volume, right? So what I'm gonna do, or a new server, I'm gonna go deploy a server. And when I'm deploying that server, I've got a ton of options. Obviously, I have to choose the location where the storage is deployed in Phoenix. And then you can pick a billing model, a consumption model, and then you have a ton of instance types to choose from, right? And so everything from large scale, brand new Ice Lake systems to, cost effective, high single thread, high clock speed instances with graphics cards enabled. There's all kinds of cool stuff that we have in the platform from a compute perspective. Once I select, I'll just go up and select one of these here. Now that'll work. Let's just do this one. Once I do that, give it a host name, decide which SSH key I want to use, determine whether or not I want to kind of configure things in an automated fashion via CloudInit, determine where I'm going to put it from a network perspective, whether I'm going to give it access to an entire subnet, whether I'm going to get a single IP address for the box, or if I'm going to not assign a public IP and instead have some type of gateway service that I'm gatewaying all my traffic through. But once, for the purpose of the storage perspective, I can say I'm going to assign this to the NFS network that was created. It'll pick an IP address out of the block if you don't want to assign one. You deploy that server, and then in this instance, you'd have that server in about 90 seconds, maybe 2 minutes running. You access it via SSH or whatever way you want, that you've designed your infrastructure to be accessed. And then what we'll do is, so we can save you guys the time and that effort, when you look at what's ultimately created here in Phoenix, you have a dedicated storage network with 2 IP addresses that are in what Rob mentioned, Vast calls them VIP pools. They can be round robin DNS together to enhance performance. So you can create connections via multiple IP addresses, increase your thread count for connectivity to storage. And then ultimately you can go and create up to 15 volumes per region today. And they can be of varying sizes with varying NFS permissions and the like. So what I've done here is I have, I'm gonna go ahead and create a new volume and call it Vast Volume. And then volume. And if you go to this server right now, you'll see that there's only one export, the one that was in the interface earlier there. I'm gonna give it a 1 terabyte size, and then I'm gonna add that volume to that. If I go back to my NFS, you can see that volume is already there. and then we can go and I'm going to, it generates a UID every time. So I'm going to go take that vast volume, and I think I've got this correct. Yeah. And then when I go DF, there's my volume. It's 1 terabyte, 932 gigs. And it's ready to roll. And it's NFS through and through. It's NFS v3 today. We're adding NFS v4. We're working with the VAST team to do some other cool stuff in the future, like exposing exposing the CSI driver integrations via these kind of data plane IP addresses, which doesn't work today if you're using Kubernetes, but we've got some workarounds that we can talk about. But yeah, if you're running an ESXi cluster, it's that simple. Make a storage volume, mount it as an NFS storage volume inside of ESXi, proceed, right? We're trying to make this almost kind of like stupid simple, and it is super fast. I mean, like super fast. I think that when we've put it through some paces, I don't know if I have anything here. I was just looking at some stuff the other day just to try to get an idea. But either way, expectations are from a perspective of each tenant somewhere around 30,000 IOPS per IP. So without even talking to us, probably can easily do 60,000 IOPS across these volumes. And then obviously, as Rob said, we have other things that we can do, right? We can build dedicated storage like processors with these C nodes in the architecture he described. And yeah, there's a lot of use cases that make this capability powerful. And we're looking for more. If you come try out the platform and you say, oh, this doesn't meet my needs, this is something I just need it to be able to do this, let's have that conversation. So I think that's, Rob, did I get everything that we want to show? I think we did.
Yeah, I think so. Yeah.
All right, cool. All right, last poll question. My marketing people want their marketing qualified leads goal to be met. So if you will please, if you want to hear anything, you want to hear about VAST data exclusively, we'll get you in their hands. If you want to know more about phoenixNAP Bare Metal Cloud without network storage, we can talk about that. The whole solution, whatever makes sense to you and your organization. I think we can move towards questions. All right. Okay, what regions can you deploy the VAST data, the network storage inside of phoenixNAP BMC today? The answer to that is Phoenix and Ashburn only, so US West, US East. We're working towards getting it deployed in the Netherlands and Singapore, and then other regions will come based on demand from clients from there. In network storage capacity limitation. Yeah, so like capacity limitations. Rob, what's the capacity limitation of VAST data? I'm not sure anybody's hit it yet.
No, none of our customers have hit it yet. The upper bound of a single cluster is in the range of 4 exabytes. We've got clusters deployed that are over a quarter exabytes, over 250 petabytes. So yeah, it's quite large.
It's quite large, yeah. I think that it meets most people's needs, right? Today in our platform, the default quota size is 3T. That's easily expandable to kind of whatever meets your needs. We have customers over 100 terabytes today. I think that should not be an ultimate concern. There's a petabyte plus per region available. So if there's any questions around capacity, we can have that conversation. Let's see here. Yeah, so someone asked about cold storage. We do. If it kind of featured there for just a second. Let me see if I can get back to the. I'll show you one thing here. So we are in the middle of launching a new storage optimized instance that will have about 16 terabytes of local NVMe. Actually, from a cost perspective, that's pretty cost effective. And then I think if you our object storage platform as well, I don't have it configured on this account, but our object storage platform offers kind of archival access to storage. You can place backups there. You can place kind of large scale analytics data that's not being immediately processed there. That starts at 1.8 cents a gig and goes down from there. So kind of in that between standard S3 and S3IA, that's kind of where the price point and performance in fact is at today. So hopefully that answered that question.
And I can jump in there and offer something that doesn't necessarily exist through phoenixNAP yet, but if there's interest, the VAST systems support snapshots and indestructible snapshots that cannot be deleted before a certain retention time. So if that is of interest as a as an anti-ransomware prevention, or it's not a backup per se, but it is a safeguard that in case your system gets compromised inside, runs wild and encrypts all its data or deletes it or whatever, that there can be generations of it through the use of snapshots. So if that is of value and of use, talk to William and his team, because the underlying technology is there to be able to support that.
100%. And I think that we're in a position to do a lot of tenant level modifications. We can't do much about the architecture. It's all automated. Everything's automated. But as Rob mentioned, like if you had some custom requirements, until we have self-service access to these capabilities, which is certainly coming. In fact, I was just showing Rob before the call, we're adding, we just added, it's via API only today, but the ability to control NFS permissions on a per volume basis is in the API. There's a couple of other things that are in there, but we're looking to expose more and more of what the VAST technology can do under the hood to the customer. And so snapshots, indestructible snapshots, we talked about CSI integration. There's a ton of stuff. And then we're even talking with VAST about kind of what he said, like having 2 tiers, which wouldn't actually be 2 tiers of storage per se, but 2 tiers of performance, and even allowing us to have a more cost-effective option for maybe not like the cold archival backups, but for customers to do the active backups, the things you would restore from immediately. I think that makes a lot of sense there. Right. Let's see. Got 2 more, it looks like. Can network storage be shared between different servers? Yes. So any server in the same location, as long as it's attached to the network storage network that's created for you, can access those exports. With the new NFS permissions capability, you can restrict that further. You can say only these IP addresses in that network have access to write, as an example. So we have that kind of granular level control via API today. But other than that, one of the main value points I think of using NFS, even though the world kind of became addicted to iSCSI, and like I would say, Rob, maybe like inappropriately related performance to like the protocol versus the storage architecture. But
I mean, I run into that a lot, where it's people attribute performance to protocols such as block, it's fiber channel or iSCSI, and get really wrapped around that, and that's actually can be very limiting from a scalability perspective and the flexibility to move through data centers and stuff like that. So with modern Ethernet speeds, the speeds and feeds coming into a VAST cluster are 100 gigabit links today, and there's many of them. So yeah, and I mean, as time goes on, those are getting bigger. So there's some pretty fat pipes to push a lot of data through, and we've overcome some of the other challenges where like a protocol like NFS may cap out somewhere in the neighborhood of 2 gigabytes per second. By leveraging something like NConnect, we can get that higher, and multi-path driver on top, we can completely saturate some links. So
Yeah, it's I mean, like I said, even as a tenant, some of the testing that I did was, my own personal account is pretty crazy, right? In terms of performance and really what you don't have to do to get the performance. That's the thing. Like Rob and I were talking before this about like, yeah, certainly EBS, GP2, you can build a ton of volumes, you can use software to RAID them together and inside your operating systems and like uh, you know, yeah, cool.
And
But
lose all
how
of
much
it
does
when
that
you lose
cost
one
you?
of them, stuff
Yeah.
like that.
Yeah, man, how do you manage that? How much does that cost? Like, there's just a lot of things. We were trying to make this a simpler game, I think is the idea. And then yeah, the consumption model is by the hour essentially. So it's 8 cents a gig a month that actually gets broken down into an hourly charge. We are bringing in reservations for storage. I can show you kind of what that looks like today for compute and bandwidth, but it'll look more like bandwidth. So today, when our customers need more than the 15 terabytes we give you per region included, they can go buy a bandwidth package for a flat fee. They can say I'm buying 100 TB egress for $144, right? The same thing will apply to storage soon, and customers will be able to come in and say, okay, I want to commit to 20 terabytes, and I'm going to get a 10% discount off of that, as I said, $86, $87 for that 20T. That's what we're building right now, in fact, and I think that will be even more flexible for customers, and really even again driving down that cost. And if you have extreme use cases where you have petabyte scale, right? We can absolutely work with you on that performance, dedication side, and on the costing side. So flexibility is the name of the game. I think that's it in terms of questions. I'm gonna look and see here some more. Let's see if there's anything else there. Nope, I think we're good. I want to thank everyone for coming out and joining us. Hopefully it was valuable and worth your time. If you want to know about anything else, please, by all means, reach out and we'll talk about it. All right. Have a good day, everybody.
Thanks for having me on. Thank you for your time, everyone.